Welcome to the Self in Society podcast, exploring what it means to flourish as an individual and a community. This is your host, Ari Armstrong. Music by Jordan Smith, cjsclassical.com. Please join my email list for updates or help to support the show financially at ariarmstrong.com. Our guest today is Jason Crawford, entrepreneur and author of the Roots of Progress blog. Welcome to the show, Jason. Thanks a lot for being on.
Thanks a lot for having me.
You write in your inaugural blog post for this project, which was March 17th, 2017, I believe that the story of human progress is the most important story in the world. I believe that understanding it is a foundation for some of the most important questions of philosophy and politics. Walk us through your thinking on that.
The motivation, the very personal motivation, for this project for me really was to find a better and more sound grounding for some of my political and philosophical views. I noticed through talking to people with a variety of views that different people don't only disagree on what the solutions to the most pressing problems in the world are, they disagree on what those problems are. So, for example, imagine a very right-wing deficit hawk is talking to a very left-wing environmentalist. The deficit hawk is very worried about our national debt, which is now over, $20 trillion, and sees that as a looming crisis. The environmentalist doesn't even understand why that's a problem. What's the big deal? Why can't we rack up some debt? You're worrying too much. Conversely, the environmentalist sees climate change as a looming threat that could destroy mankind, and that's the world's most pressing problem. The deficit hawk, the right winger says, what's the big deal? Whatever, we're burning some fossil fuels, temperature goes up a little bit, maybe. If that science is even correct, I don't know if I believe it, that kind of thing. So the two of them can't even agree on which problems are most important, or what are the things we should be worried about, let alone what the solutions are. And when I thought about, for myself, why do I care about certain problems and what do I consider important? And why do I care about, for instance, the freedom of innovators and entrepreneurs to go out and pursue their vision and maybe change the world? I thought about the history that I know of how far humanity has actually come and how low standards of living were even 100 or 200 years ago. And the incredible progress that got us to where we are today. And I realized that knowing even just a little bit about that story of progress was foundational to my worldview. So I decided, all right, if this is foundational to my worldview, I'd better understand it better. If I want to be really solid and really believe and have a good grounding for what I think is important in the world, what problems humanity should worry about and be tackling, then I should go understand this story of progress. And just thinking about it from that angle made me realize, the overall importance to the world of the story of progress.
So let's try to hone in on what, in your conception, is progress, because people who call themselves progressives today obviously have a very different idea of what progress is all about. So what is it that you're primarily interested in when you talk about progress?
I think of progress in three broad categories. Following Steven Pinker, as he talked about in his book Enlightenment Now, I think I use a humanistic standard. That is, what is best for human life, health, happiness, thriving, and flourishing. This is also consistent with and motivated by Ayn Rand's concept of morality as the basis of the good being the standard of human life. So I think from that standard, I think of progress in three broad categories. One is the category of technology and production. This is economic growth and progress and wealth. This is the category that I've been focusing on most so far in my blog. The second category, which is intimately tied to the first, is the growth of science and knowledge in general. And then the final category I think of as sort of government and society, perhaps morality. This category was covered pretty well by Pinker in his book, The Better Angels of Our Nature. So if you look across human history from where we started tens of thousands of years ago when we were living in tribal societies to now, We are immensely wealthier and have enormously more productive capacity. We know an enormous amount about the world. We have a rich scientific understanding of the world. And we are immensely freer and safer than our tribal ancestors. So we've actually made enormous amounts of progress in all three of those areas. But as I've pointed out elsewhere in my blog, one of the astonishing, amazing things about the story of progress is that virtually all of that progress in all three of those areas has been made in the last 500 years only out of humanity's history. We've had language for roughly at least 50,000 years, let's say. We've had writing for 5,000 years, but we've only had science for roughly 500 years. And we've had the Industrial Revolution for even less time than that, and the revolution of republics and democracies for less time than that. So one of the things that I think is amazing about this story of progress is that those 500 years is just 1% of that 50,000 years of language or of behaviorally modern humans, as they call it. So I think when you look at that, you have to ask a few key questions. If you care about humanity, if you care about human life and thriving and flourishing, and you realize how much progress we've made in how little of that time, you just have to ask, one, how did we get here? What was the story? What were the steps of this amazing journey? Two, why did it take so long? Right? Why did so many generations, thousands of generations, have to suffer and die for so many years before we finally unlocked these keys to progress? And three, importantly for us and our descendants, how do we keep it going? Right? How can we keep progress going and maybe even accelerate it, speed it up? Conversely, what would threaten to slow progress or stop it or even reverse it? Because we know from history that progress has been lost or destroyed in the past.
Yes, so there's ups and downs, obviously. Yet, I think the trend you summarize, you say progress is exponential. Every part of it strengthens every other part. So, what is it? What is this exponential growth of progress? What does that look like in brief? And why is it an exponential process?
Yeah. So when I said every part strengthens every other, I mean there's a reinforcing cycle of progress where many things depend on and build on so much of what came before across many different areas. So a great example of this is you just look at the early Industrial Revolution. There were four areas that all reinforced each other and themselves. So one was coal, another was steam power, another was iron, and the fourth was trains and locomotives. Right. So if you think about that, coal was really powering all three of those other processes. Steam was powering the locomotives, but also steam power was pumping bellows and working hammers in iron factories, and steam was pumping water out of mines for coal. Iron obviously was being used to make trains and rails and steam engines, all of which and implements to mine coal. And then the trains themselves were carrying the coal to and from the mines and carrying iron products back and forth. So all four of these things were reinforcing each other, and I think that's why you get these very strong growth curves. But there are less obvious examples as well. So, for instance, when I read David McCulloch's book, The Path Between the Seas, about the creation of the Panama Canal, one of the things that stood out to me was that in order to build the canal, we really depended on medical technology, specifically the emerging germ theory of disease, and the way that allowed us to tackle the threat of tropical diseases. So, yellow fever and malaria killed, I think, tens of thousands of people in the late 1800s when the French originally tried to build a Panama Canal. By the time the Americans attempted it and did it in the early 1900s, the germ theory of disease had advanced enough that doctors and medical researchers were finding exactly which bacteria caused these diseases and exactly which species of mosquito were spreading them, and were able to combat the mosquitoes and greatly reduce the deaths from those tropical diseases.
So different industries rely on each other and help to support each other. But you also talk about the intellectual angles of this. So one thing you talk about is the Republic of Letters. So explain what that was and why it was important, And then a related question is the relationship between the scientific revolution and the industrial revolution. So what I'm trying to get is the line of ideas and how they influence this development of technology.
Yeah, I think the single most important thing I found in terms of the line of ideas is the very idea of progress itself, and I'm indebted to Joel Makir for this. He wrote a very interesting book called A Culture of Growth, which really was the book that I read that cemented the idea for me that this project was not just going to be about the Industrial Revolution, but was going to be about the story of human progress more broadly. And so his one of his theses in this book is that the very idea of progress is not natural. In fact, it is a new idea in human history. So most of human history has consisted of static societies where nobody really thought that anything ever could, would, or for that matter, should change. And Joel Makir says these are characterized by a sort of ancestor worship, where the idea that our ancient ancestors were the greatest and wisest people who ever lived. All knowledge that mattered was revealed to them, and all that we can do is really study their writings and get more and more meaning, wring more and more meaning out of their texts through deeper and deeper levels of exegesis. And so this leads to a very static, sort of tradition-bound society. Now, according to Makir, this wall began to crack around the time of Columbus and the voyages of discovery, and there was a process of it crumbling that basically concluded around the time of Newton. So the voyages of discovery, we went out and we were discovering not only new routes, we discovered with Columbus entirely an entire new couple of continents that the ancients obviously did not know about. So that made people think, I guess not all of the wisdom was revealed to the ancients. Here's something that we, the moderns, have discovered that they did not know. And there was a debate raging apparently for over centuries about the ancients versus the moderns. Eventually, by the time you get to Newton's theory of universal gravitation and the solar system was just so obviously a system of understanding the world that was superior to, that was deeper than anything we had ever inherited from Ptolemy or any of the ancients. And that really showed people, really inspired the world that we, the moderns, could come up with things that surpassed. And so I think that was really key to laying the foundation for the Industrial Revolution.
So one aspect of this, which I found interesting in your blog posts, was the interest in the so-called tinkerers and inventors in the deeper science. So I think one thing you mentioned is that the inventor of the steam engine, Newcomen, actually was in correspondence with some of the English leaders of science. Could you talk about that relationship a bit more?
Yeah, absolutely. So there's this thing that gets debated, and I was just talking about it on Twitter this morning before we started this recording. That there's this idea that the Industrial Revolution wasn't created by scientists; it was created by tinkerers, artisans, engineers, mechanics, practitioners who weren't certainly not university men, not scientists, and maybe even had little formal education in science. And so, therefore, we didn't really need science for this Industrial Revolution thing. It was just trial and error. Now, there is a grain of truth in that. Certainly, many of the early Industrial Revolution inventions did not require much science, particularly mechanization of the textile industry, inventions like the flying shuttle or the cotton gin. And certainly, many of the inventors themselves were, practical men, let's say. But I think it's not true. I think it's a misleading characterization at best to say that the Industrial Revolution did not depend on science. So let's take a look at the steam engine in particular. It has been said, for instance, that the science of thermodynamics owes more to the steam engine than the steam engine owes to thermodynamics. And that, on the face of it, is true. Thermodynamics wasn't really developed until the early 1820s with the work of Carnot, and he was, in fact, or in part, motivated by making steam engines more efficient. The steam engine itself was invented in the 1700s. Thermodynamics is the wrong science to look at. It's true you didn't need thermodynamics to build a steam engine, but what you did need was the science of air pressure and the properties of the vacuum. And this had been investigated as early as the 1600s. The fact that the atmosphere has weight was demonstrated in, I believe, 1643 by an Italian scientist named Torricelli. And Robert Hooke and Robert Boyle, great English scientists of the 1600s, were building vacuum pumps and investigating the properties of air pressure in the 1600s. And yes, Thomas Newcomen, who invented the steam engine in the early 1700s, had correspondence with some of these scientists, including in particular, I believe, Hooke, in the late 1600s and early 1700s, and specifically discussed the steam engine. In fact, Hooke advised Newcomen specifically to drive his piston in the engine purely by means of vacuum. So there was actually direct influence of scientists and this knowledge of air pressure on the invention. Decades later, James Watt came along and famously invented the separate condenser, which is a more efficient, more heat and energy efficient version of the steam engine. Watt had direct contact with a scientist, today we would call him a physical chemist, named Joseph Black, who explained to Watt the theory of latent heat and how the theory of latent heat explained some of Watt's experimental results that were very puzzling to him, and that helped him invent the separate condenser. And just to throw one final example in here, a couple decades later, there was another innovator in steam, Richard Trevithick, who was making smaller, high-pressure engines that he wanted to use on vehicles. He was prototyping, a prototype of the locomotive engine. And he was experimenting with a simpler design where instead of recondensing the steam, you would simply vent it into the atmosphere. And it was a mathematician friend of his, Davies Giddy, who validated or verified for him that such a design would not be terribly inefficient, that it would only lose one atmosphere of pressure out of the 10 or 20 atmospheres that he might have been working with in his original design. And so it was that kind of help and guidance as to what would happen with this design that encouraged him to go ahead and try it out. So all three of these major innovators of the early steam era had direct contact with scientists and mathematicians who understood the relevant theory and advised them in their work. So I think it's fair to say that the steam engine actually did depend on science, not pure trial and error tinkering.
It seems to me this is an error of falsely categorizing pure science separately from applied science. And what really happens is that the so-called pure scientists often have a view toward practical implications, and the practical sciences often are looking back to and even contributing to the more theoretical side of things. Does that sound right to you?
Yeah, I think that's true. There certainly is there's a virtuous cycle, and there's a positive sort of reciprocal relationship. Some tinkering might become before some science, but then the science advances a bit. The science then redirects the tinkerers and gives them a framework and directions to explore. Then maybe the trial and error part uncovers something new. So there's really a strong back and forth relationship, I think. It's certainly not a top-down process, but it's not a pure bottoms-up process with absolutely no influence from theory either.
So one thing interesting, yesterday I read all of the blog posts from Roots of Progress. There's several dozen. And it's one thing that's interesting is just the journey. So you write a couple of years ago in the middle of 2017, the more I read, the more I realize how ignorant I am of the very basics of industrial civilization. So can you give us a sense of what you were running into that made you think that you had a lot more to learn? And then do you feel like in the last couple of years, how much progress have you made in terms of putting the pieces together?
Yes, I was very ignorant at the start, and I still feel quite ignorant now, although I've learned a lot. I would say I'm at the point where I'm beginning to see the outline of what I need to learn, and I still need to dive in and flesh out many parts of it. But yeah, just some examples. So at the beginning of this journey, I didn't know what is charcoal, and does that have any relationship to coal, and what's the difference? It turns out they're quite different. Charcoal is a product of wood, and coal is a natural substance. In fact, the charcoal is essentially a purified form of wood where you partially combust it and you're left with pretty much raw carbon. The equivalent process can be applied to coal, and the product of that is called coke, if you've ever heard of coke being used in iron smelting, for instance. Another thing I didn't actually know at all I didn't really know what steel was, and I had this idea that steel had been quote unquote invented during the Industrial Revolution. That's not really true. Steel had been known since antiquity. It was more efficient processes for steel that were invented during the Industrial Revolution. I also didn't know along those lines what smelting was. I had this sort of ridiculous misconception of smelting. I thought that ore, like iron ore, for example, was kind of a rock with little bits of metal mixed in it. And smelting was basically a process of heating up the rock to the melting point so that the iron, the metal would like drip out of the rock, and maybe you would catch it in a pan or something as it fell down. That is a complete misconception. It turns out actually iron ore or any other types of ore are oxidized metals. It is essentially a rock, but it's the metal's not little chunks in the rock. It's actually oxidized, and to smelt it, it's a chemical process where you're stripping away the oxygen from the elemental metal, and it's done in enormous furnaces where you build a huge fire and you burn the entire thing. So it was nothing like my misconception.
So, as an aside here, you have a link to this video of a guy who's making charcoal out in the woods. So I watched this, and he's literally using his bare hands, and he piles up the wood in a certain way, and then he cakes it all in with mud, and then lights this intricate fire, and then muds it all off, and then he ends up with charcoal. I don't know how many days later, but I thought, man, that's some time-consuming business.
The Primitive Technology channel on YouTube. It's a great channel.
Yeah, I was struck though by here's this guy out in the woods using his bare hands and sticks, and yet he has this intricate video system recording him and then storing the files on who knows presumably on Amazon's storage system somewhere, and then being broadcast throughout the world on these intricate cable systems and satellite systems. And it just the distinction of that struck me while I was watching that video.
Yeah.
To shift gears a bit, why do you say there are no natural resources?
Yeah, the concept of natural resource is a funny one. Nothing is a resource until we understand what to do with it and how to use it. But actually, the other point I was really getting at in the times when I've mentioned no natural resources are all resources actually come to us in a highly inconvenient form. So, for example, going back to iron, right? Iron isn't found in elemental form in nature, except in a very rare case of meteorites. But the vast majority of the iron is abundant in the Earth's crust. I think it's something like 5% of the mass of the Earth's crust. But it comes to us in the form of ore, and we have to go through this smelting process that humanity didn't even discover until a few thousand years ago. And even more than that, the iron ore itself is not found in pure form. The ore is mixed in with contaminants, impurities such as sulfur and phosphorus, and these are things that you have to deal with in the smelting process. If you don't get rid of the impurities, they can get into your metal and make it weak or brittle. So, yes, really everything that's out there. Rivers are a great example, right? So nature gives us rivers, and we can travel the rivers. But often the rivers are inconvenient. They might have waterfalls that make them unnavigable, or shallows, or rapids, or shoals. Other things that make them unnavigable. They might have winding paths, or they might just not go where we want, right? And because of this, we have to create canals. Or nature gives us some paths, but sometimes where we want to go, there are mountains in the way, and we have to create tunnels or bridges. So everything that nature gives us is not crafted for us, not optimized for us, and often not exactly the form we want. Nature gives us wind, but to sail our boats, we sometimes have to figure out how to sail against the wind, because the wind isn't always blowing the direction we want. So that's what I mean when I say there are no natural resources. Really, everything has to be shaped and molded and adapted to our purposes.
Well, one thing that I loved about one of your posts is that you explained how some of our most valued products today started off as waste byproducts, and then only later did human beings figure out, oh, this actually has a really important use if we just figure it out.
Yeah, exactly. So there was an example of that in iron smelting. There are the earliest smelting processes created a form of iron called wrought iron, which is soft and malleable enough to be worked by hammers at an anvil. That's what blacksmiths do. A later process that was developed as furnaces got bigger, the furnaces started to actually melt the iron. And iron that has melted, it turns out, absorbs more carbon and becomes hard and brittle. And so this form of iron is called cast iron. Originally, this was just seen as a waste product because if you tried to put it through the normal iron making process, it would simply break. You couldn't hammer it. But then, at some point, somebody figured out, well, maybe we can cast it into molds instead. And then cast iron became a huge industry. Another example I gave, I think, was Portland cement is a particular formula of cement, and it's made through a very non-intuitive process that there's a hard substance called clinker that you create, and then you kind of crush and grind that up, and you get this really high-quality cement. But again, clinker was originally considered a botched product. The stuff had been overcooked, and so again, it was just kind of thrown out. I think another example I gave was natural gas. In the beginning of the oil industry, natural gas was just this annoying kind of thing that came out of the mines sometimes when you were trying to get oil. And so it was often just burned off. It was annoying. It was frustrating. It wasn't the thing you were going for. Now, of course, natural gas is a valuable industrial product.
What do you think that Thomas Malthus got right in the context of him making some very big errors?
Sure. So, for context to anyone who doesn't know, Malthus was he wrote a famous pamphlet or mini book where he basically said we have a looming crisis because essentially the population is growing exponentially, and there's no way our food resources are ever going to grow exponentially. Therefore, we will hit a point where we don't have enough food to feed everybody, and there will be famine. And what did he get wrong? So he was correct that population was growing exponentially. He was wrong that that food production could not grow exponentially. It did. It grew even faster, and in general, economic production grew even faster than population. And so population rose, and at the same time, the standard of living and the GDP per capita also rose, which is an amazing achievement of humanity. What did he get wrong? Well, he didn't foresee the Industrial Revolution. I think you got to give him some credit for that. I think that was a very hard thing to foresee. I have only read the first few chapters of his book, but it seems to me that he was basically arguing from a failure of imagination. His argument was, well, come on, you can't really seriously be telling me that we're going to grow our food resources more than linearly. I mean, I just can't imagine that. That was kind of what his argument comes down to in the first few chapters. He doesn't argue anything. He doesn't offer anything more than that. But to his credit, he was basically supported by all of history up until that time. He was writing just at the dawn of the Industrial Revolution, and I think looking back at history, it would have been difficult to impossible to predict what was actually just about to happen.
In one of your blog posts, you discuss why you're not sure why there couldn't have been at least a linear increase in food production even before the Industrial Revolution. In other words, with more population, why couldn't the more population grow more food as they went? So have you given any more thought as to, outside of the context of an industrial society, what are the inherent limits to increased wealth production?
Well, I did write a follow-up blog post to the Malthus post where I discussed some reasons why that might be. I don't think I have a full answer here. Certainly, some of the productivity is limited by land. So if you don't have modern agricultural technology, you're limited in, you can't just necessarily grow more food if you have more laborers. You also need good, fertile land. There were also, I think there could also have just been some social and political type of barriers. Land being divided up among someone's heirs, for example, so that each heir got a smaller and smaller plot of land. If you don't have sort of a robust capitalist market for people to go, find land, or for that matter, for them to go find other work, or perhaps to feed everybody, you need some population migration to places where there are better opportunities. If you don't have the transportation technology to get people there, or for that matter, the communication technology for people to even find out about those opportunities, then mobility is practically limited, even if theoretically there are other opportunities for people. So I think we can see a few factors, but I don't have a full answer.
It occurs to me that it must have been impossible for people writing in the time of Malthus to not think about humanity's overriding reliance on farming, because almost everyone farmed. You can see before you and in recent history examples of famines, whereas today only a tiny fraction of our population actually farms. I can't remember the exact number. And we have such a global economy that even if there's a complete wipeout of all crops in some region, given the trade, people don't starve unless there's overriding political problems on top of that. So maybe it's worth thinking about how different the mindset must be between us today, who we don't even, at least in America, we don't even ever think about the possibility of actually having a real shortage of food. It doesn't even cross our minds. Whereas back in that time, that had to have been a constant and continual concern.
Yeah, exactly. Not only do we not think about having a shortage of food in today's world, I don't know about you, but I barely even think about what foods are, quote, in season, right? You walk into a grocery store and you can find fresh fruit of almost every variety, year round. Um, and so, yes, we are amazingly advanced now, and this is one of the great achievements of industrial civilization and of humanity is that we can feed ourselves. Shortages of food and famines today, I believe, are essentially political problems, not technological ones.
What do you think of the theory of the low hanging fruit in the context of technological development? In other words, the idea is, well, sure, we had enormous growth and progress in the 1800s and 1900s, but that is slowing largely because people have already made the relatively easy discoveries. And now new discoveries are incrementally more difficult to make as you go. Does that, do you think there's any truth to that?
I think there's some truth to that. I don't think it's too much to worry about. So there was some interesting debate about this, and there was a good blog post on the blog slatestarcodex.com, which is one of my favorite blogs, where he talked about it looked at essentially exponential progress, but being essentially we've put exponential resources into the exponential progress. So if you look at that, the resources we're putting into progress grow exponentially, but the rate of progress in terms of percent, percent of whatever metric you're improving per year is constant, right? A constant percent rate of improvement means exponential growth. So why is it that we're putting exponential resources into maintaining the same percent rate of growth every year? And I think this low-hanging fruit hypothesis kind of makes sense. If you look at physics, for example, in the 1830s, Faraday could discover fundamental new laws of physics, basically by playing with magnets and, some scientific instruments on his table at home. Today, you have to have enormous teams of scientists spending large amounts of money to create the Large Hadron Collider or the LIGO apparatus. And so, yeah, it's probably true. We've picked the low hanging fruit. Certainly, that's true with some industrial resources as well, like oil. Right? I mean, the easy oil that was kind of right below the surface, and even where it was seeping out of the ground, I think is mostly gone. And so now we are drilling deep under the surface of the ocean, for oil. These things are true, but I don't know if that's just part of the way the world works. I think and we can keep the progress going.
I also think there's something to it. However, I also think that there could be some major game changers in the not too distant future. So, the two obvious examples, if there is a revolution in nuclear energy, we could multiply the amount of usable energy for this same or comparable cost by several or even many fold. And that would be a huge game changer. The other possibility is, as Robert Zubrin predicts, when we start going into space more, that opens up possibilities not only for much faster Earth to Earth transport, but then creating colonies off world and then even getting into the mining of asteroids. Have you thought about the possibility of those kinds of major technological breakthroughs? And is there any other that I missed besides the two that I mentioned?
So absolutely, major breakthroughs like that are or can be in our future. I think that's part of why I say we can keep the progress going. Um, the Earth is an enormous ball of natural resources. If you look at it the right way, that resources are things that can be used by the mind and by industrial processes. Um, we have literally only scratched the surface of the Earth's resources. And yes, and then of course the Earth is just a tiny dot in the solar system, which is a tiny dot in the universe. So there's a whole universe full of resources out there. Literally, everything in the universe is potentially within the scope of what something that we can use. I like the perspective of David Deutsch in his book, The Beginning of Infinity, says basically anything that is not forbidden by the laws of physics is possible given the right knowledge. And so it's just the growth and advance of knowledge and the further developments of infrastructure, and all of those resources are awaiting us.
I'd like to go on a quick whirlwind tour on a selective history of some of the major inventions in the Industrial Revolution. So you've talked about the steam engine. Talk about the significance in terms of its wealth-producing capabilities of first the Newcomen steam engine, which was the early 1700s, and then later that century, the Watt steam engine.
Yeah. So the steam engine was the first time that we had a source of energy other than natural sources, right? So prior to the steam engine, to make anything move, you either had to move it yourself or get an animal to move it, so you had muscle power, or you had essentially wind and water power, right? But wind and water sort of blow and flow where they want and when they want, and they might not be available when and where you need them. Muscles can be moved to and invoked when and where you need them, but they're limited in power, and you can't if the horse isn't driving your water pump fast enough, you can't really design a more powerful horse. So the steam engine was a way of taking stored energy, taking fuel, which prior to the steam engine, fuel could only be used to produce heat. It could be used for fire, for cooking, for smelting, for boiling water, and so forth, but it couldn't be used to make anything move. So the steam engine was the first thing that connected fuel to motion, and therefore gave us a source of power that was scalable and that could be brought anywhere we wanted and invoked at any time. And so its first major use, Thomas Newcomen's invention, was used for pumping water out of mines, which was crucial to mining below the water level. And then decades later, when Watt came along and made the engine more efficient with his separate condenser, it could be then used for all sorts of things. It could be used in factories. It could be, and ultimately, of course, we made mobile versions of it and powered locomotives and steamboats and so forth.
How did Fritz Haber and Karl Bosch turn air into bread?
Yes. Turning air into bread is the great phrase from a really good book called The Alchemy of Air, which is about this thing called the Haber-Bosch process. In brief, it is a process that turns nitrogen gas and hydrogen gas into ammonia. Ammonia is NH4. And the importance of this is that ammonia is the precursor of synthetic fertilizer. So in the late 1800s, the world was, as we were ramping up agricultural production, we were running out of fertilizer, which is absolutely needed to grow food. We were running out of natural sources of it, and it could be seen that there was a looming crisis, an agricultural catastrophe and famine ahead if we didn't find some way to produce synthetic fertilizer. The challenge is fertilizer requires nitrogen. Nitrogen is the most important ingredient for plant food, basically. And even though nitrogen is abundant in the atmosphere, it's 80% of the atmosphere, plants can't use atmospheric nitrogen. They can only use it in other forms, where the nitrogen is incorporated into different molecules. Because the triple covalent bond in a nitrogen gas molecule, N2, is a very strong and very difficult to break. So the Haber-Bosch process is a industrial chemical process that does break that bond and bonds it with hydrogen to make ammonia, NH4, which is the precursor of, again, synthetic fertilizers and also, for that matter, explosives. So it became very important in wartime. The fascinating thing about this book, The Alchemy of Air, is that it goes into not only the chemistry and the industry of it, but also the politics, because the process was invented in Germany in the early 1900s, so right around the world wars.
I thought it was funny. One thing you write about is before this process was invented, there were literally bird poop mines. And this was a big industry for some time.
Yeah, absolutely. So there was this particular island off the coast of South America that I guess it was very dry. It never rained there, and there were a lot of birds in the area, and so there were literally, I think, tens or hundreds of feet, like stories and stories of accumulated guano from seagulls. And it turned out it was some of the best known natural fertilizer. So yeah, they mined the guano and shipped it off all over the world.
So the most boring thing in the universe has to be concrete. So what's so great about concrete?
Yes. Concrete or cement is this technology that if it hadn't already been invented, if it weren't 10,000 years old, it would sound futuristic. In fact, I almost feel like I could fool somebody for at least 30 to 60 seconds telling them about this amazing new scientific futuristic material, liquid rock. It's like instant stone, just like you can have instant pancake mix in powdered form. We have stone in powdered form, and you just add water, and then you can pour it like a liquid into any shape, into any mold, and it will set as hard as rock. In fact, it is rock. I describe it that way, and it sounds like something you might see in some science YouTube channel, but that's actually cement. That's what cement is. So cement comes from rock, and it essentially is rock. And in particular, it's limestone, which consists primarily of the element calcium carbonate. And what we do, this is the amazing thing about cement, we take the limestone, you sort of crush it and burn it and turn it into calcium oxide. Then you add water and you pour it into a mold. And as it sets, it reabsorbs carbon dioxide from the atmosphere and essentially turns back into calcium carbonate. So it goes through this whole cycle where it begins as calcium carbonate in the limestone, and then it ends again as calcium carbonate in the hardened cement. So we're basically taking rock, we're literally taking rock, turning it into powdered form, and then reconstituting it, at a place and time and in a shape of our choosing. And I think that's a pretty magical technology.
How do most people take their cotton shirts and other cotton clothing for granted?
Well, it's funny. If you look down at your own shirt or pants right now, I find it hard to believe that this thing actually came from a plant, or an animal, right? Those things in nature, they just seem so messy. And you look at modern, industrial produced textiles, and they just seem so clean and regular and synthetic. And, some of them are synthetic. If you're looking at nylon, that's a plastic. But you're looking at cotton. That originally came from a plant. It grew in a field. It was picked off of the plant in a cotton. Cotton comes in the form of what are called bolls, BOLL, and it's basically a ball. It's a ball of messy cotton fibers. It's mixed together with dirt and debris, and in particular, in the case of cotton, with seeds. The seeds have to be removed from the cotton, and that's what Eli Whitney's invention, the cotton gin, did much more efficiently than picking them out of the seeds by hand. Then the fibers have to be straightened, and this is done through a process called carding, where you kind of comb it with kind of a comb with metal teeth, and the fibers all sort of straightened and made parallel to each other. Then they need to be spun and kind of twisted and elongated in just the right degree to create thread. And there are machines to do this now, too, of course. And then the threads themselves have to be woven in a crisscross pattern, at right angles to each other in order to make cloth. And those are just the major steps. I mean, I'm leaving out a bunch of bleaching and dyeing and so on and so forth. So it's a very long, intricate process. And before the 1700s, of course, it was all done by hand, sometimes with very simple machines that one person would work by hand, like a spinning machine. And today, of course, it's a massively automated technological process. And you can see videos on YouTube. It's really amazing how some of these machines work and how fast they work and how intricate the working is. And so the end result of all this is that the cost of cloth and of clothes has dropped by orders of magnitude since the 1700s.
Doesn't everyone who listens to NPR know that plastic is destroying the oceans and blighting the land? So why do you call plastic an amazing and vastly underrated substance?
Well, it is amazing. So if you think about the materials that were available before the plastic, so in the pre-industrial age, you basically had stone, wood, metal, clay, glass, and textiles, and maybe a few other things you might throw in there like paper. And of course, animal products. This is not a comprehensive list. These are kind of the major categories. And now just imagine, taking somebody from the 1800s or 1700s or before who's never seen or heard of plastic And just imagine them encountering this material for the first time. It's much lighter than stone or metal, but it's hard and solid. It holds water. It doesn't corrode. It can be easily made into any shape imaginable through a wide variety of techniques. It can be poured into molds or injected into molds. It can be milled or sanded or polished. Um, Perhaps most amazing, it can be made into any color we want at all, or even made transparent. It can be made hard and solid, or if you make it thin, you can make a bag out of it. Right, it's flexible. So it's really this material that after we spent the 17 and 1800s mastering the materials of nature, metal and wood and concrete and glass and pottery and so forth. We spent a lot of the early industrial revolution coming up with better ways to work with these materials, ways to make them higher quality and more consistent and cheaper. Finally, by the end of the 1800s and really the early 1900s, it was time for us to surpass nature, to create a new material, to add our own material to the list of the things that nature gives us. And that's what plastic is. And it just has all these amazing properties. And if you just look around you in the world today, try to go a day and try to just count all the things that you touch or work with that are made of plastic or have plastic in them somehow. It'd probably be easier actually to count the number of things that do not have any plastic in them. That's how ubiquitous it has become in our world.
So I was being a bit facetious before talking about NPR, but there does seem to be a problem in some areas with pollution of the oceans. Do you have any opinion on the cause of that and what people might actually do about that?
No, that's not an area I've looked into yet. I think it's an area we should take seriously, although I think it's funny, pollution and the idea of say recycling plastic or so forth. It's I see it as kind of some of the same analogous to, if you think about food. The problem with food through most of human history is we didn't have enough of it, and today, because of the agricultural technology that we discussed and many other technologies we haven't discussed, food is so abundant, so reliable, and so delicious that we have to restrain ourselves from eating too much. Right? The problem now is obesity, not famine and nutrition. And with plastic, it's sort of a similar thing. The problem, a big problem with materials all throughout human history, is that they degrade. Metal rusts, wood rots, and so forth, right? And so we finally created this material that is so resistant to all forms of degradation. It's basically immortal. And so now our problem is, how do we get rid of it? Right? How do we dispose of this material when we're done with it? So it's a real problem, but I think it's a very good problem to have, historically speaking.
And it occurs to me that whatever technology people implement to clean up some of these problems will probably almost certainly involve a lot of plastic themselves. So it can also be part of the solution in almost every way.
Yep, that's usually the way it works.
Why do we wait so long for the bicycle, which is the title of one of your blog posts?
Yes. So this was a question I posed on Twitter, and I got a lot of interesting hypotheses in response. So for context, the bicycle was invented in the 1800s. Really, the bicycle as we know it today, we didn't arrive at that model until the late 1800s. And yet, it's one of these inventions that doesn't seem to rely on any scientific theory. Unlike the steam engine or the electric generator, the bicycle is a mechanical invention. And so you got to kind of wonder, well, why didn't we have bicycles much earlier? Why weren't there bicycles in the Roman Empire or in ancient Greece or some earlier time when people were tinkering around with mechanical inventions? So I posed this question on Twitter. There were a lot of replies and theories. I went kind of hunting around, and people had lots of ideas. Some people said it was because the roads weren't very good. Some people said it was because of competition from horses. Other people said, well, you needed rubber for tires or, precision machining for gears and chains. And these things are all relevant. They're all good hypotheses. Some of them start to break down when you look at them. So, for instance, roads are not really the answer. People did ride bicycles on dirt roads, on sidewalks, even over cobblestone streets, which were very bumpy. The roads didn't improve really until after the bicycle got popular, and I think it was in part pressure from cyclists that led to the improvement of roads. So I looked into the history of the bicycle to understand why this was. It turns out for hundreds of years, since the 1400s at least, people were thinking about powered vehicles, human-powered vehicles, that is. But they were almost always thinking of them in the form of four-wheeled carriages, kind of large vehicles with multiple wheels and possibly even multiple passengers. And some versions of this were even built as early as the 1700s, but they were all impractical, I think basically because they were too heavy, they were too large. What we needed, the breakthrough that was needed for the bicycle was to think not of building a mechanical carriage, but something more like a mechanical horse. And this breakthrough was finally made in the early 1800s, 1817, I believe. A German forestry minister called Karl von Drais invented the prototype, the earliest thing that we could look at and call a bicycle. It had two wheels and a seat in between. What it did not have was pedals. So in order to use this velocipede, they called it, or the Draisienne, you had to basically kick along the ground like a scooter, or like there are some models of this for children today, where they, instead of pedaling, they kind of kick along the ground. So that was fun, and it became a fad on the continent and in England for a year or two. People got upset at these velocipede riders because they were going through public parks and on sidewalks and getting in the way of pedestrians, which is exactly what's happening today in San Francisco, by the way, at the scooter wars. So some things never change. But again, these things had no pedals. They were a fad. They kind of died out. People kept experimenting with models. Finally, somebody put pedals on the bike. It's unclear exactly when this happened, but it definitely happened the latest in the 1860s in France. But the original pedals were attached to the front wheel directly. And because of this, you didn't get a lot of mechanical advantage. It was kind of like being stuck in first gear the whole time. The bikes also at this time were made out of wood or maybe cast iron. And the tires were often made out of wood, maybe with iron rims. So they were very rickety. One model of bike in the 1860s was called the Bone Shaker. So that gives you an idea of how bumpy the ride was. So to solve both of these problems, what happened was people started making the front wheel much larger. So this both gave you better mechanical advantage, and it absorbed shocks better. But it led to the ridiculous-looking design that you've probably seen from the late 1800s with an enormous front wheel and the rider perched way up high. It's called the penny farthing design. And this design worked well, but it was very unsafe. As you can imagine, you can't just put your feet down to stop yourself or balance if you lose your balance. And if you hit a bump, you would just fly. You just tip right over, fly right over the front. So it was a very dangerous design. Eventually, in the 1880s, there was a successful design called, in contrast, the safety bicycle, which was essentially the modern design. The two wheels were much closer to evenly sized, equal sized, and the pedals were in the middle, connected to the wheels with a chain, rather than directly connected to one of the wheels. And then a few years later, in the late 1880s, pneumatic tires were introduced. I guess before that, we had solid rubber tires. Vulcanized rubber, by the way, wasn't invented until about 1839, I think. So we had solid rubber tires, but then finally somebody invented or reinvented pneumatic inflatable rubber tires, and those absorb shocks better. So between the safety bicycle design with the pedal and chains, or the gear and chains, which gave you better mechanical advantage, and the inflatable rubber tires, we finally were able to shrink the front wheel again and have essentially what we would recognize as the modern bicycle by about 1887 or 88. So looking back at this, why did it take so long? Well, part of it was just the design is less obvious than it may seem, right? The correct design needed, it was kind of centuries of people thinking about the problem before someone came through this basic breakthrough of the two-wheeled, one-person design. And then it was decades of design iteration before we actually arrived at what we would call the modern bicycle. Second, I think you can see that material and manufacturing technology was relevant here. The vulcanized rubber, improvements in metalworking, the ability to make hollow tubes, the ability to make them out of steel, which is lighter per unit of strength, the ability to make wire spoke wheels, precision machining for gears and chains. All those things seem pretty important to getting to the modern bicycle. But finally, as I speculated on in the blog post, I think there are more, deeper sort of underlying cultural and economic factors here. One of the economic factors is just GDP growth. In general, you need a certain level of surplus wealth to invest in R&D. For GDP per capita, I think has to reach a certain level before people are going to even have time and energy to think about anything that doesn't put food on the table or a shirt on their back or a roof over their heads. And then, and note, by the way, so the early invention of the proto bicycle, like a lot of early science and technology inventions, was created by a baron, an aristocrat, who was somebody who had extra money and therefore extra time to kind of play around with science and invention. But also, GDP growth is sort of needed to create even a market for these things. Once you have a middle class, you have people who can actually buy bicycles, right, and aren't, again, just scraping together the bare subsistence. And then the deepest cultural factor, perhaps, is just the very inventiveness of the age itself. And that goes back to what I discussed earlier, the very idea of progress, the idea that we can and should be trying to find new and better ways of doing things. So I think all of those factors contributed to the bicycle happening where it did. You can see, by the way, you can ask the same question about about inventions that are even simpler, that did not require advanced mechanical techniques, and that were even more obviously important to production and wealth. And I think particularly if you go back to, as I mentioned before, the mechanization of the textile industry, the flying shuttle is an example that economic historian Anton Hauss likes to use. It was literally 2 blocks on a piece of string, but it doubled the productivity of weaving at broadcloth looms. It took it from 2 weavers being needed down to 1. Or the cotton gin is another one that I've blogged about. It was a very simple invention, basically a drum in a box with some metal teeth and a wire mesh, and yet it dramatically improved the productivity of separating, processing cotton balls and separating them out, the cotton lint out from their seeds. So for both of these, I think you can ask why. There were very simple mechanical inventions. The cotton gin was so simple that when word of it spread, plantation owners were making bootleg copies in their sheds. That was how simple it was to create. Eli Whitney actually had a hard time enforcing his patents and could never make a lot of money off the cotton gin because all these people making bootleg copies. So these very simple mechanical inventions were not invented until the 1700s, and yet they had this huge impact on productivity in core industries. So I think even more than the bicycle, we can see there's some sort of cultural and maybe economic factor at work here. But I think there's a key cultural factor of inventiveness that I haven't totally nailed down yet. But Joel Machier's idea of progress is the best one I've found so far.
You have some really fun pictures of you carving stones and making cotton strings. What other sorts of artisan tasks have you tried, and what have you learned from doing this?
Oh, yes. So I've done a few things. I took a spinning class where I learned how to spin wool into thread on a drop spindle. I took a weaving class where I learned how to use a simple hand loom to better understand that relatively complicated, sophisticated machine. I did try my hand briefly at chiseling stone at one event, and I also took a blacksmithing class, which I haven't had a chance to blog about, where I took a small iron bar and pounded it into a bottle opener with a little bit of ornament on it. So I have tried my hand at a few of these crafts.
In what ways, or do you think that progress today is threatened? And if so, what can we do to preserve and expand the progress that we've enjoyed so far?
Yeah, I think there is an important sense in which progress today is at risk for a couple of reasons. Obviously, progress in many ways is going pretty strong. There are people who argue that it has slowed down, or that the computer technology has sort of been like the one exception, maybe to economic progress. Peter Thiel is big on this thesis, and Robert Gordon wrote a book. I think it was titled "The Rise and Fall of American Growth." So I haven't made up my mind yet on whether progress is slowing down by the numbers, and whether that's significant or just kind of a part of a natural S curve, and a new S curve will pick up, say, in biotech in the coming decades. But I do think I see cultural reasons why progress may be at risk. And this is a big part also, again, of the motivation for turning Roots of Progress not just into a personal project for me to understand, but into a blog for the world to understand. I think most people don't understand or appreciate progress. I think, and it's very understandable why not. They don't learn it in school. It sort of falls between the cracks of history and science class. They don't get it from the news media, which is has a strong negativity bias. They say if it bleeds, it leads. They don't really get it from popular culture, which I think has grown increasingly dystopian over the last several decades. And it's very hard to get on your own. If you go and sort of read books, maybe even about the history of science and technology. The ones that have the most information are very dry, dense, academic. The ones that are most readable are, sort of infotainment, right? They're kind of popularized histories that focus a lot on. They give you little kind of mind snacks, but they don't necessarily give you the big picture of progress, which is one thing I'm trying to begin to communicate in my blog. They also tend to focus a lot on the human drama, which is maybe fun and entertaining and memorable, but it doesn't help you appreciate what were the actual problems that humanity has faced and what were the technological solutions to them, or the scientific solutions, or the political and societal governmental solutions. Um, I think, in contrast, Steven Pinker's book, Better Angels of Our Nature, did a much better job of giving the big picture of social progress, at least along a certain dimension in terms of reduction of violence. And he even goes into what were some of the actual mechanisms and patterns. So, that kind of appreciation for industrial history, for scientific history, for other aspects of government and society is kind of what I want to give. So I think progress is at risk because we don't appreciate it. I also see progress is under attack from multiple angles. So you see the rise today of anti-tech narratives in the media. Tech is invading our privacy. It's isolating us from one another, and so forth. Which there might be some truth to, but I think are exaggerated and spun into a broader anti-tech narrative. We see, there are the sort of romantic or ideological wing of the environmentalist movement spreads fear about technologies that are perfectly reasonable and helpful, such as GMOs. We even have the rise of conspiracy theories like the anti-vaccination movement, which is bringing back, measles and other epidemics. In general, I think there's sort of a growing distrust of elites and institutions, and I understand where some of that comes from, but it's leading to attacks on, I think, some of the elites and institutions that are the foundations of progress, such as startup founders and venture capitalists, or scientists and universities, or even courts and the rule of law. So I see threats to progress. I see the potential for populist political movements that would attack the foundations, or that would propose policies that would essentially take us backwards. When you don't understand when you don't understand where we've come from, it's easy to kind of romanticize the past as some sort of Garden of Eden from which we have fallen, and to propose going back to it without realizing, if you don't see the modern world as a set of solutions to problems, it's easy to propose essentially unsolving problems that we have already solved. But the biggest thing I worry about, even more so than politics, is the next generation. If young people today don't hear the story of progress, and if all they hear are these attacks on it, and they don't realize how far we've come, how are they going to be motivated and inspired to actually participate in the story of progress and to take it forward? And if the next generation doesn't take progress forward, progress is going to slow down or stop or be reversed, because it only happens when we make it.
Well, I'd like to switch gears now and talk more about some of your other projects.
Sure.
And I hope that the Roots of Progress continues at full force, because I agree with you that we desperately need things like that. I know that, so you worked on something called Fieldbook for a number of years, and that could be a show unto itself. But briefly, what was Fieldbook, and what were some of the main lessons you learned by working on it?
Yeah, sure. So Fieldbook was a tech startup. I was the co-founder and CEO from 2013 to when we shut it down in 2018. Fieldbook was an information tool that was basically like a cross between a spreadsheet and a database. It was aimed at all the people who use spreadsheets for things that spreadsheets were never really intended for. Right? A spreadsheet is kind of designed and optimized for really like the finance and accounting department, right? Things like financial models, or budgets and income statements and things. And all the time, people use a spreadsheet more like a little database. For instance, as a project tracker, project management tool, or as a lightweight CRM, that's customer relationship management for sales, or as an applicant tracking system, for recruiting and so forth. Almost everybody who's been involved in business has kind of used a spreadsheet this way, at some time or other in their career. Um, and spreadsheets just get very frustrating for that. They were never really meant for that kind of purpose. They aren't optimized for it. You really want something that's more like a little database application. So that's what Fieldbook was. It let you basically build and manage a little database app with a user interface that was kind of as familiar and intuitive and natural to use as a spreadsheet. Worked on it for a few years, launched a product, raised a seed capital for it, hired a small team, launched a product in market. We had paying customers and some very loyal users, but at the end of the day, we just didn't grow the revenue fast enough. We weren't profitable, and after 5 years, it seemed like it was still going to be a long, hard slog to profitability. So we ended up shutting the company down and selling the team in what's known as a talent acquisition to a company called Flexport. Looking back on it, I think I had the right idea at the right time and basically messed up the execution. I say that because in the last year or so, we've seen a number of similar applications become quite successful. Most notable is probably Airtable, which seems to be the most successful of these applications and also is the closest in sort of spirit and in mechanism to Fieldbook. Um, there's some others as well. There's one called Notion, one called Coda, some apps that are similar in spirit, such as Webflow or Retool or Bubble. And you can look up all these if this area interests you. Looking back on it and contrasting what we did with what some of these other companies did, I think there were a couple of big mistakes that I made. And I explain these in a post-mortem on my personal website, jasoncrawford.org. And one of them was the way that we marketed and sold the product, really the way that we aimed and focused the product. I'll explain. Any product like this has many features that you build into it. In your marketing, you can only really focus on a small number of features. You kind of have to pick a few things to be the flagship features that you put front and center and you really focus on in your marketing as the key selling points. And then you have to focus on those things in your onboarding as well. So when someone signs up for your product, if it's a free product that, or a freemium, with maybe a free tier and then a paid tier, you're typically expecting people to sign up and figure out how to use the product themselves rather than going through a sales process or a training process where you teach them how to use it. And so you've got to figure out what features, what flagship features am I going to put front and center in my marketing and then sort of teach people how to use in the first 15 or 20 minutes of them playing around with the product. And at Fieldbook, we chose to focus on the way that you could link sheets together to create what in technical terms is known as a relational data model. We called it, that we try not to use too many technical terms in our marketing, so we called that, sheet linking, or some people like to call it a multi-dimensional spreadsheet. But it turns out we arrived at that through user research, through talking to people who had very complicated, difficult spreadsheets that were causing them a lot of pain, who seemed to be the users who needed our product the most. And that was the key feature they needed the most for their use case. But it turns out, I think that was a mistake in retrospect, given the freemium business model that we had, because that feature is a somewhat technical feature, and it's therefore difficult to explain. We kept trying to come up with terms to communicate it, but it was very hard to put in the marketing and have people instantly understand what that meant and whether they needed it. And even the people who intuitively got it and were excited by that feature or excited by our demo video, when they used the product, they had a hard time figuring out exactly what it was good for. It's kind of a paradigm shift to go from a two-dimensional spreadsheet to something that lets you build a relational data model. So we had a hard time, with our customer acquisition cost, getting people and turning them into active, long-term and ultimately paying customers. In contrast, if you look at, for instance, Airtable, Airtable had a very similar product, but they just put different features front and center, both in their marketing, in their onboarding, and of course what they focused on in terms of their product development. In particular, they emphasized a lot the mobile interface. So they had a great iPhone app, which we never had a mobile app at all. And then also the collaboration features like notifications and comment threads, which also we never really built. And those features are much simpler to for people to understand and much easier for them to get started using. So I think that was probably one key thing that made Airtable and other companies like them succeed where Fieldbook failed. The second major mistake I made, I think, was I simply vastly underestimated the resources we were going to have to invest to build a launchable product in this space of information tools. I thought I could do it for well under $1 million raised and just a couple of people maybe working for a year. And I really should have budgeted more like a minimum of 3 million to just to build and launch the product, and a team of, say 4 to 6 working for a year or two. And what I learned from this, so it turns out that information tools are a very mature space. They've been around for a long time. You're basically competing against free products from Google. And so the bar is set very high, and the bar for features, polish, and performance is pretty high before people are going to be willing to even try your thing for very long, or certainly switch to it from their free Google Sheets. So the lesson I learned from that is that if you go into a project and you have underestimated the resources you need by, say, 20%, then when you get towards the end of your resources, you can tell at least that you're getting close. You can see the light at the end of the tunnel, and you just need a bit of a bridge to get there, to mix a metaphor. But when you underestimate the resources you need for a project by 3 to 5x, then when you get close to the end of those resources, you don't even see the light at the end of the tunnel. And so you don't even know if it is a tunnel that you're going through or just a cave that you're going deeper and deeper into that's a dead end. And so you begin to question everything. Question, are you on the right path? Are you the right person to do it? Are you, is this, should we completely change our strategy? Is there even a market here? And that can cause a lot of thrash, and it can cause you to do things like we did. I think we launched too early before the product was really polished and developed enough and ready to grow fast. So those are kind of the biggest learnings coming out of that experience.
If a young person comes to you and they want a career in tech, what sort of advice do you offer them?
I wrote about this a little bit on my blog as well. I try to give them some career advice from Mark Andreessen, who wrote a great series of blog posts back in 2007 about career management. And a couple of key points, I recommend reading the whole thing, but a couple of key points that I emphasize. One, you should go straight to the heart of your industry. So if you're in tech, you should really come to San Francisco unless you have strong reasons to be somewhere else. I made the mistake early on in my career of thinking that I should just look nationwide, find the best job opportunity, and then move to whatever city that job happened to be in. What I didn't realize was you actually spend longer in a city typically than you spend in any one job. If you move to a city to get a job, your next job is more likely to be in that city than in another city, just because of the way networks work. You meet people, and a lot of times your next job might come through somebody you know. Or you might put down roots, and it might just be hard to leave an area. So it's actually more important to figure out what is the most dynamic city for your industry with the most opportunities. Go there, and then find the best job opportunity you can find within that. So I encourage young people who have no other ties, if you want to be in tech, come straight to the San Francisco Bay Area. The other thing that I didn't realize was that if you want to really grow your career, you should optimize for a company that is growing fast. The growth rate of the company is strongly tied to the opportunities for growth in your career. If you're at a slow-growing company, it's just hard to find opportunities to take on big projects, to rise into management, or to become a more senior engineer and so forth. Whereas if you're at a company that's growing very fast, they're desperate for people who can pick up as much responsibility, as possible and run with it. So fast-growing companies are the ones that are where there's the most opportunity for personal and professional growth. And it turns out that tech companies sort of go through an S-curve throughout their life, where they start off growing very slowly before they've found what Mark Andreessen calls product market fit. Essentially they've found the product that really works in the market and can grow sales very fast. They can spend months or years searching for product market fit, and most of them, in fact, never find it. That's the real risk with joining a company that early, is that they won't take off, they'll never grow, and you'll kind of be stuck stagnating with them. Then once they do find that right product, right market, they tend to grow very fast if they've hit a big market, and they go through a period of hyper growth or very fast scaling. And that's when it's very exciting, little chaotic, but basically the rocket ship is taking off the platform, and you just have to hang on, for dear life. as it and remove all obstacles to that rocket ship's path. And then eventually, when companies get near the limit of their addressable market, let's say, they tend to level off. Things kind of plateau. The growth slows very naturally, and they get big enough that not everything that's going on anymore is a project that's crucially important to the company. Even at a large innovative company like Amazon, which even at its size, one of the biggest companies in the world, is still amazingly continuing to innovate. It's possible, and it's not too hard at Amazon or any company of its size, to kind of get sidelined on a project that just isn't that important to the company overall. Whereas if you join a mid-stage, say, Series B or C type company that is still, say, valued in the hundreds of millions of dollars, not yet a billion-dollar company, but they're growing very fast, doubling or tripling or more every year. At a company like that, nobody is working on anything that isn't crucially important to the future of the company. There's just no room for any such projects. Everybody is working on something that's absolutely necessary. And there are huge foundational systems to get put in place that don't even exist yet. And there are completely unoptimized things that just need to be optimized. There's just all this high value opportunity everywhere you look. So I say, go to, Andreessen calls it a young, high growth company. I would characterize it as a, early to mid stage hyper growth startup. That's where the best opportunities are.
Another interesting project that you've gotten involved in is called Free Objectivist Books for Students, which is freeobjectivistbooks.org. How did you have the idea to set that up? What was its purpose, and how has it operated?
Yeah, sure. So this site is a site where any student can sign up to request a free book by Ayn Rand or about her philosophy of objectivism, and then we have donors who sponsor the books, and we send them to you in the mail. I created the site basically because I think Ayn Rand is underrated and that more people should read her books, particularly her novels Atlas Shrugged and The Fountainhead, which were very influential on me. And the site originally, I just had this idea that I was wondering if I could get more people to read a book like Atlas Shrugged if I just promised to buy it for them. So I originally put out a call on Facebook, I guess, and I said, hey, dear friends, I will buy any of you a copy of Atlas Shrugged if you promise to read it. And so I just wanted to see who would take me up on this. And I got exactly 0 takers for this offer. It turns out my friends are perfectly capable of buying books, and it's really time that's a limiting factor for them, not money. So, nobody took me up on it. But I thought there might be something to this idea. And so I tried again, but this time I put it out as broadly as possible, and I offered it not only to my friends, but anybody in the world. And I just decided, you know what, I'll sponsor the first 10 books myself. And if I get more than 10 requests, maybe I'll go out and ask some other people I know to sponsor, and buy some books. And I got 50 requests. And they mostly came from students. And I realized, of course, students are exactly the right audience for this. They're the ones who feel strapped for cash and might read a book or not, depending on whether, somebody sends it to them. And, I thought just the very idea that somebody cares enough about these books to put them out there for free and send copies to a student they've never met really kind of says something about how powerful and impactful these books are and how much they change people's lives. So I set up the site, and now, like I said, any student can sign up. You just give a little bit of information about yourself, and you write a few sentences or a paragraph on which book you want to read and why, and then we'll try to find a donor for you and ship the book. To date, since that project began in, I think, 2012 or so, we have sent out over 10,000 books to students around the world.
Wow, I had no idea it was that many. What have students said who have received these books? What kind of feedback are you getting?
Oh, yeah, it's great. We have testimonials on the site. You can go and read them. It's very impactful. People are really fascinated by the deep ideas in here, especially the idea of individualism. The idea that your moral happiness, your happiness is the moral purpose of your own life, and just the permission to think that way, I think, is very liberating to some people. So we've had a number of students write back to us and tell us that it changed their lives.
So I believe that all of your writing is collected at jasoncrawford.org. Is that correct, or is there some other place people need to look?
That's my personal blog, yes. And then the Roots of Progress blogging that we started talking about is at a separate site, rootsofprogress.org.
I'll put all the links in the relevant page show notes. So, do you have any closing thoughts just to wrap up the discussion? Where do you go from here in terms of researching the roots of progress, and how does this fit together with your broader life projects?
Yes. Well, I am trying to figure that out right now. I have recently left a job and I'm exploring opportunities. So I'm looking at things in the tech industry, of course, since that's been my career. But I'm also looking for potential ways to take Roots of Progress full time. I think that we need to somebody needs to tell the story of progress to the world, tell it as an amazing, fascinating story, and in some sense the greatest story in human history. Someone needs to counter all of those attacks on progress that I mentioned, counter them with rigorous, empirical, well-researched truth, and someone needs to promote the idea of progress as a noble quest, especially among the younger generation. And that's what I want to do and will continue doing in one form or another.
Well, I hope that people listening will consider ways that they could support your project, because I think it's very important and very interesting. And even just the work you've done so far is just a great resource, I find.
Thank you. And I do have a Patreon. So if you're interested in contributing some amount per month, however big or small, check out Roots of Progress on Patreon.
Well, thanks a lot for being on the show today. That's been really insightful. I really appreciate you coming on.
Thanks, Ari. This has been a great conversation. Really appreciate your having me.
This has been the Self and Society podcast. Our guest has been Jason Crawford, author of the Roots of Progress blog. For more, please see ariarmstrong.com.